Hello everyone, welcome back to my video tutorial. This time I will be talking about superellipse. A superellipse is a closed curve defined by the following simple equation: x by a power m plus y by b to the power m equals to 1, where a and b are the size, positive real number of the major and the minor axis, and m is a rational number. M equals to p by q has to be greater than 0, right? Where p is an even positive integer and q is an odd positive integer. If m equals to 2 and a equals to b, we get the equation of a circle. I am going to demonstrate this. For larger m, however, we gradually get more rectangular shapes until m is close to infinity. The curve takes up a rectangular shape. On the other hand, when m tends to 0, the curve takes up the shape of a cross. Alright, this part also I'm going to demonstrate it. So superellipse are special cases of curves which are known in analytical geometry as Lamy curves, where m can be any rational number. Alright, Lamy curves are named after the French mathematician Gabriel Lamy, who was the first who described these curves in the early 19th century. Alright, this is an example of a superellipse, and as you can see from here, when m is equals to 2, we have this circle. Alright, when m is greater than 2, we have somewhat a rectangular shape, and when m is less than 2, here in this case m is equals to 3 by 5, which is 0.6, we have a curve like this. Alright, I'm going to demonstrate all these things. And so Python, a Danish scientist, writer, inventor, popularized these curves for design purpose in 1960s. Alright, so faced with various design problems, Python proposed a shape that mediates between circular and rectangular shape and named it superellipse. So any shape that mediates between circular and rectangular shapes is named superellipse by Python. Alright, so Python also made a generalization of superellipse to 3D, which he named superellipsoid or superspheres. So when we try to generalize the superellipse into three-dimensional, it is called superellipsoids. Alright, so I'm not going to read all these things. I'm going to give you notes for this. And this is a 3D version of a superellipse. That means it is a 3D ellipsoid. Alright, so before we move on, in your browser type desmos.com, and as we know, we already have a formula for superellipse, which is given as this. We'll just type in the, here you go to graphic calculator, here put x divided by a to the power m, okay, plus y divided by b to the power m, which is equals to 1. Here if you would type a power, you use this, okay, and when you put divide, you simply use this symbol. Alright, so we need, for all these variables, we need a slider. So I'm putting a slider here. Now as you can see from here, when let us just decrease this from, let's say, 0 to 5, m also 0 to 5, b also 0 to 5. Alright, so let us put a equals to 2 and b equals to 2. Then make it constant for now. You can play with it. And when m is equals to 2, as you can see from here, when m is equal to 2, it becomes a circle. Alright, so when m is moving towards positive infinity, see, we are getting a rectangular shape. Alright, so when m is moving towards 0, the curve is shrinking. Now when m is equal to 0, we get a straight line, xy line only. When we move out, we are getting a circle. Alright, so we are simply modifying the equation of a circle. In the equation of a circle, this m is replaced by 2. Alright, so here this is called a superellipse, and if m is greater than 2, that means when we get a rectangular shape like this, when m is greater than 2, when we get a rectangular shape, it is called hyperellipse. And when m is less than 2, it is called hypoellipse. Alright, these are the types of superellipse. So just put it here. So when you reduce the size of m, you're getting a cross-like structure. Alright, and when m is equals to 1, when m is equals to 1, you get a rhombus. This is your rhombus. Alright, so let me type it here. When m equals to 1, we get rhombus. Alright, that is all for superellipse. See you in the next class.